Okay, so we've got one more example problem we're going to do from this section. And definitely make sure to look at the homework questions from this section. I do want to make clear though, I mean, sometimes people focus too much on this section and not on the other sections that are covered here. Remember that on the exam there's only going to be one question from this section. So if you focus all your efforts on this section, you get that question right, but everything else wrong, you really haven't internalized most of the chapter. Alright, so let's look at this last one here. So we are making a box whose base has its length 3 times its width. The material for the top and bottom is $10 per foot squared, and the sides are $6 per foot squared. The volume of the box is 50 cubic feet. Find the dimensions that will minimize cost. Alright, so this one's, I think, there's a lot of kind of things going on here, and so we have to, I think, be a little bit more careful on this problem. So first off, we're making a box, and I will go ahead and try and draw a box here. Not too bad for freehand, not great, but not too bad. And one thing we want to do here right now is maybe just label some things that we know. For instance, I'm going to just call this here W for my width, and then I'm going to call this L, which is 3W. Actually, one thing I forgot to do is we're always supposed to write down what we're optimizing. So we're trying to minimize cost. Alright, so let's go ahead and get back to this then here. So we have width of this box is W. The length, it says, is always 3 times its width. So length is 3 times W. And then I don't know the height of this. I'll just say the height of this is H. Okay, so then let's write an equation down here. So one of the things we know here is that the volume of this box is 50 cubic feet. And of course we know that volume is simply length times width times height, which is going to be, well, 3W, because that's what the length is, times W times my height. So this is 3W squared times H. So I have that 3W squared times H is equal to 50 feet cubed. Well, actually, I don't have to write the feet cubed at this point, but that's fine. Now, we're trying to figure out the cost here. So I'm going to need an equation for cost. So let's get the equation, what I think are some of the easy portions of it, or let's just write all the sides here. We have top, bottom, front, back, left, and right. Now the nice thing is the top and bottom are the same, the front and back are the same, and the left and right are the same. So let's first look at the top. So I will go ahead and just highlight on our picture here. The top would be what I'm highlighting in red right now. So that would be the top of the box. And we can see the dimensions of that. So the dimensions of the top would be W by 3W. So the area of the top is 3W squared. Whoops, hit the microphone with my pen there, sorry about that. Now, again, we're trying to minimize this cost, so what would the cost of the top of the box be? Well, if I scroll up here, the top and bottom costs me $10 per foot squared. So this is the area, so the cost of the top is going to be 10 times 3, I'm writing down the answer, times 3W squared, which is of course 30W squared. Now this is also the cost of the bottom, because the bottom is going to be the exact same dimensions. Alright, so now we need to go through and do the front, back, left, and right. So let's look at the front here. I'm going to highlight in blue now the front. And so the area of my front is, well, 3W times H. Okay, great. Then the cost, though, for the front, because these are the sides, $6 per foot squared. So the cost of front is $6 times 3WH, which is 18WH, which is also the cost of the back. Alright, one more side to get here. I'll go back up to my picture. I know I'm having to scroll back and up a lot, but it's the only bad thing about this. And highlighting in green the left side here. And so the dimensions of that left side would be W and H. So the area of left is WH. So cost of left is 6 times WH, which is of course just 6WH, which is the cost of the right. So now that we've gotten to this point here, we're ready to finally write down an equation for my cost. So I'm just going to do C for cost is equal to, well, it's going to be the front and the back. So I'm going to, top and the bottom is what I'm going to do here. So this would be top is 30W squared plus the bottom, which is 30W squared, plus the front, which is 18WH, plus the back, which is 18WH, plus the left, which is 6WH, plus the right, which is 6WH. And so my cost becomes 60W squared plus, math here, arithmetic, what is that, 12, 30, 48? 48WH. So that would be my cost here. Now, we also have a problem here. We've gotten all this work to get this equation, but we still have two variables here. We have W and H. So we need to go back up and look at another equation here. And that's where we had that 3W squared H is equal to 50. So we could solve this equation here for H. You could solve it for W, but it probably makes more sense to solve it for H. And we get that H is equal to 50 over 3W squared. So we have C is equal to 60W squared plus 48 times W times, and I'm having to scroll back up here, 50 over 3W squared. Alright, so then let's simplify this out. So my cost is 60W squared, and then 48 times 50 divided by 3 is 800. And this would be W to the minus 1. So now we have to solve this. Not solve it, take first derivative and find my critical numbers. So I take a first derivative of this. I get C prime is equal to, if I could take a derivative properly, 120W minus 800W to the minus 2. And again, we're going to want to find the critical number, so I'm going to set this equal to 0. So we get 120W minus 800 over W squared. 800 over W squared is equal to 120W. So we could write this as 800 over 120 is equal to W cubed. Nice thing about cubes is there's only one answer. So W is equal to the cube root. So let me go ahead and do that. So it's the cube root of 800 over 120. Just punching it into my calculator here. And I get that this is approximately 1.88, and this would be, my units are in feet for W. Now, I'm just scrolling back here to see what we're trying to find the dimensions that minimize the cost. So we have W is equal to 1.88. Now, before we do actually write our answer down, we have to verify that we have found a minimum. So I'm going to go ahead and just use the second derivative test on this, since I have the first derivative sitting right here. And the second derivative test, if it's easy to find the second derivative, makes it so I only have to plug one number in. So C double prime is equal to 120, and then this would be plus 1600 W to the minus 3, which I would need to evaluate this at 1.88, which would be 120 plus 1600 over 1.88 cubed, which is clearly positive. And if you just write that as clearly positive without writing the number down, that's fine, because all we're interested in whether it's positive or negative to determine whether it's concave up or down. But I'll go ahead and compute the number for us. And when we do compute the number, we get 360.8. And again, it's positive, so that means I'm concave up. And I have indeed found a minimum. Now I need to just finish answering the question. So to finish answering the question, well, we know that W is 1.88 feet. We know that my length is equal to 3W, so that would just be 1.88 times 3, which is 5.64 feet. But then we remember, scrolling back here, we had that 3W squared H has to equal 50. W squared H equals 50. So 3 times 1.88 squared times H equals 50. So solving that, now I'll just plug it into my calculator. You get H is 4.72 feet. And so we're done with the problem. Alright, and speaking of being done with the problem, we are done with this section. We are done with section 4.4. And then remind you that on class on Monday, we will have opportunity to go over homework questions on sections. So just to remind you here at the end of the video here, so on, what would that be, the 29th, go over homework problems. If you don't have questions, we will move on. If no questions, we will move on to section 4.5. And then on 1031, remember, we'll have a quiz. And for sure, this is going to be 4.1 and 4.2, maybe 4.4. I'll let you know by Monday. And I had mentioned at the beginning of the other video that you will be allowed to work in groups. All right.